Hey guys, welcome back to the 5th Taylor series video. Now in this video, I'm actually going to spice it up and it's going to be really exciting. So I hope that you guys enjoy it and I hope you guys subscribe to the channel. All right, so let's begin. Take the function natural log of x and take the derivatives as many times as you would like. Now, one thing before we do that, I thought I wrote somewhere around here that we're going to center this about x equals 1, but I think I forgot to write that, and that's okay. Basically, we can't center it around x equals 0 the same way that we did with sine and cosine, only because at x equals 0 for the natural log, it's undefined. So we're going to center it around x equals 1. How do we do this? We take the function natural log of x and we take the derivatives many times, and that's what we do here. So here's f of x. You guys have to know the derivative of the natural log of x is 1 over x. Now, to get the next one, I just want to show you guys something. I'm sure everyone knows that you guys are in calculus, but I just want to make sure that you know. Okay, I'm not going to assume anything. You bring up the x to be -1, it becomes now -1x to the -2. The third derivative, you do the same thing, it will be +2x to the -3. The fourth derivative, I should really put a 4 there, would be -6x to the -4, and so on. And so what I did here was, second derivative, I rewrote as -1 over x squared because we know that negative exponents go on the bottom. 2 over x to the third for this guy, and then -6 over x to the fourth for this guy. I substituted the x equals 1 as my next step into each one of these, okay? Natural log of 1 is 0. Then when I plugged in 1 into each one of these x's here, my solution was basically the numerator. So this gave me a 1, this gave me a -1, this gave me a 2, this gave me a -6. Great. So now that we did that, how are we going to write out this Taylor series? Well, I already wrote it out for you guys, okay? Because I wanted to save time so I could show you something more exciting. So, first guy, I'm actually going to try this out for the first time. The first guy is 0. That's him. The second guy is going to be f prime of c. That's him. And then x minus 1. Remember, this time we have not x minus 0 like we did before. We have x minus 1, okay? So you guys have to be very careful to see where it's rotated around. Then we have, as I mentioned before, x minus 1. And then this guy would be the -1. This guy will be the f to the third, or the third derivative of f is going to be 2. And I just did the fourth derivative, which is -6, to give you this idea. Okay, so let's rush through this. This actually, got to take that off. This actually gives me some sort of polynomial of x minus 1 minus x minus 1 squared over 2 factorial. That's 2. Plus, now guys, here, x minus 1 to the third, 2 over 3 factorial, 2 over 6 is just 3. You guys see a pattern there? Minus 6 over 4 factorial is going to be the same thing as 4. Yes. So these do not have factorials in the denominator, but their exponents match the denominator. Okay, so that's how we do natural log of x. Now it's centered about 1. So let me show you what this picture looks like and how it compares to the approximation. In this problem here, this is the number 1. Okay, the blue is the natural log of x. We know that because it is, natural log of x looks like that. Now, the red is this polynomial that I reduced, which was x minus 1 minus x minus 1 squared, which is the approximation over 2, x minus 1 to the third over 3, and so on. This looks like this. Notice how the red and the blue move away from each other after the number, let's say, in this case, really like 2 or so. In other words, this is centered about 1, so you should use it to approximate numbers roughly around 1. Okay, otherwise the approximations are not going to be accurate. So that's how we do the natural log of x. So I hope you guys will stay here. I'm going to show you guys the next part of this. I decided to do the Taylor series for 1 over x centered about x equals 1. Now, I did this for a specific reason and is staying in this video for a specific reason. I'm sure all of you already know why or can see why. So I took the function 1 over x and I took the derivative many times. So I ended up with all of these. You guys are just going to have to trust me or pause the video and try it yourself. I plug in 1 for each one, and then remember that in order to estimate it or get an approximation, you're going to do 1 plus, well, negative 1. Okay, so let me get rid of that. Negative 1, x minus 1. Okay, and the next one. And some of you are probably saying to yourself, oh my God, that looks like, yep, that looks like, so 2 over 2 factorial, they'll cancel out. And then the next guy would be, negative 6 over x minus 1 to the third over 6, which is 3 factorial. So, guys, this approximation looks like this. And if you guys recall, and I hope you do, if you guys recall, this is going to be the most beautiful thing I've ever done in my entire life today. If you guys recall, definitely need different colors. Natural log of x, okay, is equal to the integral of 1 over x dx. Or you can say the derivative of the natural log of x is equal to 1 over x. So if you took the derivative of this guy here, okay, you would get exactly this guy here, right? So in that case, if I integrate this, I just want to show you the integral of this is very important. The integral of this guy, well, when you go to integrate 1, most of you are probably going to say, oh, that's just x to the first divided by 1. But you're centered somewhere else, so you have to make sure that you take that into consideration. So this is going to be x minus 1 to the first over 1. This guy here is going to be x minus 1 squared over 2. This guy over here is going to be x minus 1 to the third over 3. And this guy here is going to be minus x minus 1 to the fourth over 4. And if you integrate all of these and you integrate 1 over x, you get the natural log of x. So if you take a look at this guy and compare him to this guy right here, they're identical. And that's the beauty about this. You can take the derivatives or the integrals of functions to get other functions. And so we're going to need that a lot later on, okay? But that's great. So basically my point was, had you known that 1 over x was the derivative of the natural log of x, and you knew what the natural log of x's approximation or Taylor series looks like, you could just take that derivative and you'll get this without doing all of this work. So I hope you enjoyed this. Come back for the next video. I'm going to start introducing the power series. All right, so I hope you guys enjoyed it. Make sure you subscribe.